let me just kind of introduce myself. I'm Ali Kafel from Red Hat, as I mentioned before. I'm relatively new to Red Hat. I've been at Red Hat for 4 months, but I'm not new to the industry. I've been doing networking and NFV for a number of years, and I was actually working for a company earlier, and we were working with Red Hat, and that's how I got connected with some of the folks at Red Hat. So when I decided it was time for a change, it was good to connect with the folks I had met at Red Hat. So, so what I'm going to talk about, I'm certainly familiar with Red Hat's products. I'm going to talk about our philosophy, our products, and I'll open up for questions after the presentation. But before I do, I was going to ask the question. I know some people in the room have experience in NFV. I assume everybody has experience in NFV in this room. Is that true or not true? You don't? Okay. All right. Then I have like 2 or 3 slides on NFV, so I'll go through those for your benefit. For those of you that know NFV, please allow us to do that. So one of the drivers of the marketplace, Brian talked about this, some of the telcos have talked about this, is this problem with bandwidth growth that's happening all over the world, regardless of which statistics you look at. The telcos are having a big challenge, enterprises as well, where the cost to support data traffic is increasing significantly, but the revenue from those data services is not growing as much, right? And we're all culprit of that. We're all offenders of that. We all have smartphones, and we do videos on it, all you can eat. But when you have that traffic going through the network, it's obviously creating stress on the network. And if you use traditional gear, it means that the telcos have to spend more money to really support that bandwidth, and that's a problem. Because the existing network is very inflexible, it costs a lot, it's very, very rigid, and it doesn't scale very well. And typically the telcos have to plan for peak time, which means they over-provision, it costs a lot of money, and it's a lot of waste. So the goal is to replace that with really virtualization. So to virtualize the network with a multi-vendor network functions using commodity hardware. So it's taking this traditional model. This is really the part of the NFV slides, if you've seen them, where each of those boxes that cost a lot of money are rigid, and move it to a cloud environment where you have a virtualized infrastructure that's managing a pool of dynamically allocated resources in a cloud environment, so that the resources above, like the VNFs using resources, they can scale out and scale in as needed. And this way, you really don't have as much waste. So the network becomes much more efficient. And because it's based on commodity hardware, it's much cheaper. And because it's based on software, it's more flexible. So there is an architecture that is being sort of used as the standard for NFV. So OpenNFV is really the consortium. Brian talked about that. That really has a reference architecture that talks about the lowest layer being the physical layer, compute, storage, and network. You've got the virtualization layer, which includes compute, storage, and network as well. You've got the VNFs on top of that. You've got the operation support systems above that. And then on the right-hand side, you've got this thing called the MANO, which is the management and orchestration. And the MANO is made up of 3 functions. The bottom is the virtualized infrastructure manager, which is done by OpenStack. But then the other 2 functions, the virtual network function manager, or the VNF manager, and then the NFV orchestrator, those are typically not part of OpenStack, and they're additional software. So that's the accepted standard for an architecture. So, and of course, one of the stipulations is that it has to be based on open source. The telcos have all pushed for that because they believe that open source helps them avoid this concept of vendor lock-in, and it gives them more flexibility to choose from the vendors they want, and that's really why they've pushed for open source. So the benefits of NFV. So when you do all of that stuff, going from that hardware-based architecture to software-based architecture, you get these benefits. Of course, lower costs is always a benefit, but the increased flexibility to dynamically scale out and scale in as needed is also a benefit. And then, of course, finally, it's to offer new services and then eliminate vendor dependency. So that's the quick sort of overview for NFV, for those people that are new to NFV. And if anybody is interested, after this, give me your business card and I'll send you the slides if you're interested in them. So now let me talk about the 5 Ps for success in NFV and OpenStack. So Red Hat is being fairly successful in obviously providing an NFV using OpenStack to telcos around the world. And we believe there are really 5 key principles that have enabled us to do this. And those are principles that we believe everyone should follow if they want to do it themselves, or if they're not going to do it themselves. Do it yourself mean you go and get everything in open source and build your own NFV infrastructure. Yes, you can do that for people that have the resources. But the reality is a lot of companies don't have the resources that it takes to go pull it from open source, put it all together, integrate it, test it, support it. It's just really complex. But certain companies have the resources to do that. They're very, very large companies. And if they do, they have to follow the same principles to be successful. And I'm going to talk about each of these 5 Ps, the people, process, projects, products, and partners. These are really the ingredients for success. The people. And of course, I'm going to relate it to Red Hat, give Red Hat as an example, how we conform to these principles. So having the right people that are working on really the solution is very critical. People that actually know the open source communities and open standards. People that have experience working, contributing, and collaborating with these communities. Because a lot of people think of NFV, obviously, we tend to talk about OpenStack a lot. It's a key ingredient of NFV. But so is the Linux operating system. So is KVM, the hypervisor. So is QEMU, the hardware emulator. libvirt, the library virtualization. OpenVSwitch, DPDK, which is the data kit for fast packet for accelerating packets. OpenDaylight for SDN to do the networking. And then finally storage, Ceph. So these are really the components of community platforms that are put together to create NAV. So OpenStack is a big part, but it's not just OpenStack. And sometimes people, I think, kind of forget that. The other thing that's really important is that the people that are involved in creating the NAV solution, they really need to know the market needs, problem statement on how to solve them. And they also need to understand that when you deploy NAV in a carrier network, in a telco network, there are some requirements that may not be the same as enterprise. Requirements as it relates to reliability, availability, manageability, performance, and security. I'm going to talk about those. So people is first. The second is process. The process of creating that solution is also very important. Chris mentioned earlier in his talk this morning, Chris Wright from Red Hat, and he said that culture is more important than technology. And he was really talking about the people and the process, these 2 points that I'm talking about. So the people side is important, as we've discussed, and following the right process is also important. So having a mindset of 100% open source, standard-based with no secret sauce. Those are the principles, actually, of Red Hat. Everything we do is open source, upstream first, as Chris mentioned. And quite honestly, for a new person coming into Red Hat earlier, I didn't quite understand and appreciate what upstream first meant until I got to really learn about it and be informed. And essentially what it means is we never, ever take code and fork it. when we fix a bug or when we make a new product, before a product is made, we write code for the upstream community. We work with the community to make sure that it gets accepted first. If it doesn't get accepted, it doesn't happen. And think about that. That's really tough to do. You know, when you're working with a community, you're working with a lot of smart people who have, you know, a lot of great ideas and also very, very strong opinions about things. Getting them to agree takes a lot of work. But we believe the benefit of that outweighs the discomfort of working with folks. So this mentality is really critical, because once you fork code and you start making changes to it, it's very, very hard to go back and catch up, because really the community is much more capable of creating things than any one company. The next point there is same software stack for all customers. So the other thing is we don't have special software stack for one customer versus another. Even NFV, even though I mentioned there are some functionality we've put into OpenStack to make it NAV that's specific to telcos. We don't have separate product for telcos and separate product for enterprise. It's all one. It's really a good habit to keep it clean. And then finally, projects versus products. It's really very important. Everything we do in the upstream community, they're projects. So when you work on projects, people are creating code. The code that's up in the project, even though it gets tested before it gets accepted, it doesn't get integrated with other projects until you pull it down and actually go through the process of integrating it. So we spend a lot of time in communities to work on different projects. We don't make money that way, right? Obviously, we're in the business of making money. But when we do the community work, we don't charge anybody anything. It's our contribution to the community. But when we pull it down and we create integrated products, and we stabilize them, and we test them, and we support them, that's when they become products, right? And ultimately, telcos or other large customers don't want to deploy project-based code in their network. They want to deploy product-based code in their network, because that's what gives them the peace of mind. So process is important. The next is projects. So what projects do you work on? The reality is there's over 1 million projects out there, open source projects. So which one do you work on? Well, that's where the experience comes in. Really for Red Hat, this is just really part of the projects. As I said, there's over 1 million projects. But specifically for the area we're in, there's probably about 100 plus projects. So we work on, and essentially there are two sort of project type thinking. One is the upstream projects. That's where you have the 1 million plus, in our case, for what we're focused on, say 100,000 plus projects. But then, you know, once some of these are integrated together into community platforms, that's sort of the next phase. And then from there, we take that and then we create products. So, you know, for example, in Linux, you know, you've probably heard there are different sort of community versions of Linux. There's Fedora, which is what we support. You've probably heard of Ubuntu as well. Obviously, that's made up of a lot of upstream projects that create Fedora. We focus on Fedora. For OpenStack is RDO. That's the community platform. And then the others that are there. And so from those is really where we create the products. So let me talk a little bit about kind of our products and our product strategy. I'm trying to keep my eye on the time so that I can leave some time for questions. So really we have, as I mentioned, the OpenStack platform is a production-ready product that we offer to the marketplace. We take it from the upstream community, from the community platform. We harden it, we integrate it, we test it, We integrate it with other functionalities, such as the carrier class features that I mentioned before, optimize with other products, and then we provide it to our customers. And in addition, the other thing we do is spend a lot of time certifying partners, because at the end of the day, infrastructure products by themselves don't add a lot of value if you don't have partners that have the right applications, that have the right hardware. So we have the largest list of partners in the industry as it relates to NFV. So what we do is the foundation for the Red Hat OpenStack. If you're a bit familiar with OpenStack, there are several services in OpenStack. There's some core ones, such as Nova, Neutron, and the storage side. And then there are some optional ones, such as the Ceilometer, which is for monitoring. You heard that spoken about earlier. Data processing, orchestration for heat is the service that's optional. But this is what we do. But the other thing we do is there's the OOO that you see over there, which is really the community platform that we create Director out of. And Director is really for deployment and management. So this is really what creates the platform. So if you remember this picture that I mentioned before, this is the sort of high-level model of the ETSI. The ETSI, by the way, is the European Telecommunication Standard Institute. It's become sort of the de facto standards organization that really defines the requirements. So ETSI defines the requirements for NFV. And then OpenStack is really the community that creates a reference architecture made up of different upstream projects that I mentioned before. So if you remember this picture, this is sort of the high-level architecture. We have created our NAV platform that really conforms to this architecture. And I know this is a little bit of an eye chart, but I think this kind of really puts it all together. On the bottom here, and the colors, actually everything in red is what Red Hat provides. And everything in the green over here is really other vendors. And then this sort of blue is really partners that we have. And then the white is optional from Red Hat. The red is part of our NFV solution. The white is optional. And then the blue is really the partners. And it's really very important to just sort of talk a little bit about this. So, you've got at the lowest level from a software infrastructure, we've got the Linux platform, which is critical. And within Linux, there are a lot of functionality that we've put in. For example, one of them is this high availability, which I'm going to talk a little bit more about in a minute. But then above that, you've got OpenStack. OpenStack has the compute function, storage, and network. But if you notice that there are a lot of small boxes in each of these. In compute, for example, we've got KVM with real-time support. That's one of the additions we've made. And again, everything is open source. It's all community-based. And then if you look at network, in there, we've got the Open Daylight support. So Open Daylight is an SDN controller. It's one of the open source SDN controllers. And we have made that as part of our OpenStack offering. So we include it. So when a customer gets OpenStack from Red Hat, they also get the Open Daylight controller as part of it. Now, they can go and pull it down themselves because it's all open source. But the fact that it's part of our OpenStack means that we've integrated it, we've tested it, and so on. So the other is on the additional functions we've added. So, carrier class, carrier class and enhanced platform awareness features, and I'm going to talk about those. SRIOV, that's for packet processing. So this is all the stuff in red. And then one other element above here is Cloud Forms, which is really the management product that is based on ManageIQ, which is an open source project. Again, everything we do is based on open source. And then finally, we've got the partners. So let me talk a little bit about partners. Partners, of course, they're certified hardware partners. And the certification process is really very important because before a partner is considered certified, we make sure that they go through some testing, some validation to make sure everything works together. Because ultimately, if there's a problem with a certified customer, when a customer calls us, it means that we will support their request, and we will work with the partner to get the problem resolved, whatever that problem is described to be. But of course, any VNF could run on top of the platform. They don't have to be a certified partner, but if they're certified, it just makes it a lot easier for the customers. So that's the solution. So the other part that I mentioned is really ODL. Earlier this week, there was an ODL summit. ODL stands for Open Daylight. It's one of the SDN, open source SDN controllers. We actually showed a demo of the integration of ODL, the latest version of ODL, which is the Boron. We actually, because we make a contribution in ODL in this entity called NetVirt, which is really the piece of ODL that actually creates network configuration, network virtualization. So we actually showed a demo of that, how easily you can send a command from OpenStack into ODL. It created a small network just for demo purposes, and we actually had traffic kind of going through it. One of the things, it was really interesting, one of the things that people asked me, they came to the booth and they said, and at least 3 people did this, is that, well, hold on a second, why do you need an SDN controller in OpenStack when there's already Neutron as the networking piece? And the answer is Neutron is a basic networking service. When you have a complex network, Neutron is not enough. You need something more sophisticated, and that's what the SDN controller does. Now, the nice thing is within Neutron, you can provide a plugin for an SDN controller, and that's what we did. So I talked about carrier class requirements, and I talked about reliability. Reliability is making sure that no matter what happens, the service is stable and it's consistent. If there's a failure, it gets recovered instantaneously, and there's no disruption in the service. High availability is to make sure that the service is always available and it's redundant, and if there's a fault, that fault is taken care of. So availability and reliability sort of go hand in hand. Manageability is also important, and that's something we added. And there's 2 aspects of manageability. One is to make sure that there's no service impact during serviceability. In other words, if you're upgrading a device, if you're upgrading OpenStack, you don't have to bring the system down. So that's one aspect of manageability. The other aspect of manageability is to make sure that you have automated deployment of new services during the whole life cycle. The next is performance. My colleague earlier, Mark, talked a lot about performance. And performance really, when we talk about performance, in my mind, there are 3 things to performance. Although some people will say scalability is a separate entity, not performance, it's scalability. But really, I kind of think of 3 things. One is throughput. How many, thousands of million packets per second can you push through? The other is response time, making sure that your latency is very low. And then the third is to make sure that you can scale out. So we've added some functionality. I'm not going to go into the details here, but for those people that may be familiar with it, CPU pinning is really where you pin one VM to a CPU. That way you don't have things swapping back and forth and causing latency problems. NUMA is non-uniform memory addressing. which is for VNFs that take a lot of memory. You want to make sure that you don't take the default. NUMA is really a concept where you want to make sure that the memory you use is tied closer to the network interface card that you're using. And then huge page is to make sure you have, a bigger memory than the default. Accelerated packet processing is come in two forms, whether it's SRIOV or OVS DPDK. So all of those things we've added. And then finally, security. So I'm going to talk about each of these a little bit. I've touched on the performance, so let me skip through. Security. This is too hard to read. This is really just an interpretation of some of these things. But essentially, when you talk about security, there are a lot of aspects on security. You want to make sure, and some of the things that I will touch on quickly is when you have a process, you want to make sure that a process executing is isolated. If a problem is with a process, it doesn't bring down the other processes that are running in the system. You want to make sure that you don't have, spoofing that's going on in your network, where packets may come in pretending to be packets from inside. You want to drop them. You want to make sure you're able to do encryption when necessary, and this is part of the requirements from the US government. You want to make sure you have identity management, including role-based access. These are all some of the things that are really critical for making sure you have a secure network. So this is all part of the NFV solution that we talk about. Let me talk a little bit about manageability. When we talk about manageability, I mentioned you want to make sure that there's no service interruption when you upgrade your system. But you also want to make sure when you onboard a VNF that you do it in a consistent way. You want to make sure the life cycle of a VNF is managed properly. So it turns out that the way you manage VNFs in an NFV environment is very similar, at least a subset of that is what really cloud management platforms do. So cloud management platforms, as defined by Gartner, really talks about the ability to support heterogeneous clouds, multiple virtual infrastructure manager, full stack integration, inventory management, and so on and so forth. When you look at this cloud management platform or any, and compare it to any cloud management platform that's in the marketplace, for example, ManageIQ. ManageIQ is an open source cloud management platform that we contribute to. When you look at that and you compare it to what the Mano functions are in OpenNFV, you can see that there are a lot of things in the cloud management platforms that are already available that Mano could take advantage of. However, there are some things that are missing, things that are specific to carriers, things that, for example, define a standard way of creating VNFs, things that talk about service availability and continuity. They're not there. So what we've done is we looked at the community-based open source Mano initiatives that are going on, and there's really two major ones. This open source Mano, OSM, some people call it, and OpenO. The problem with those is they're not based on general cloud management platform today. So what we did is we've kicked off, we actually had a demo of a project. Actually, ManageIQ has a community already. That's a cloud management platform. We've extended that. We've invited really the community to help us extend ManageIQ to solve this problem of a consistent Mano. Because the reality is today, telcos obviously are deploying NFV, but they also deploying other cloud-based solutions that are not NFV. And having a cloud management platforms that can do both really cuts down on the redundant number of cloud management platforms that are out there. So we actually did a demo at the OpenNFV Summit in Berlin. We actually showed the deployment of an NFVI, which we have, a Vim, which we have, but also an NFVO. And the NFVO was based on Tacker. And we actually ran it in this configuration with ManageIQ, playing the overall, Mano, functions. And the VNF we used was really the Clearwater IMS from Metaswitch. We also had a container. We had OpenShift running the Clearwater in a container on an Amazon Web Services platform. Because what ManageIQ can do is really manage not just an OpenStack, but it can also manage Amazon Web Services. It can manage VMware. So we actually showed this demo. And what we ask in the community is to really join us. Is anyone who is interested in being part of this community is really welcome. You can come talk to me. You can send an email over to this email here, or you can just go to the community and register. Because we think having a consistent cloud management platform will be essential. So let me just talk a little bit. I mentioned earlier that we've had some good success with OpenStack. And I mentioned we're really on the road to having 1,000 OpenStack customers. This slide is a little bit old. It says 350 plus. So these are some of the customers we have. And the telcos, the two, we actually have several, but two that I mentioned here. Verizon is the largest. They have over 5 global data centers with over 2,000 nodes today. And we have a few others as well. So the last P that I wanted to talk about was partners. So, for those of you that are familiar with Metcalfe's law, that states that the value of a telecommunication network is proportional to the square of the number of connected users of a system. And this is no different. When the more partners you have, the more useful really a network is. And so with that, Red Hat has spent a lot of time building a partner ecosystem. We've aligned with partners that include everyone you see here, Dell, Cisco, Nokia. We also have different ISVs. These are some of the SDN one. And if you remember this picture that I showed you before, I said partners was a big part of that. This is really some of the partners we have, Red Hat NFV partners. Not all of these are certified, but as I said before, not every partner needs to be certified in order for them to use our platform. But a good number of these are already certified. So to really sort of wrap up, we are the top contributor to OpenStack and Linux with upstream first philosophy. We co-engineer products, integrate them, and that's how we're able to optimize and really support our customers. And we have the richest third-party certification matrix that you saw earlier. That was just a sample of it. So really, I think this concept of people, process, projects, products, and partners is really the model that we believe provides success in NFV and OpenStack. So with that, I've got about 5 minutes, I think, for questions. Any questions? Okay, let me give you the mic.
So I've been hearing that upgrade is really a very hard thing. And so if you're like a Red Hat customer, is your life keeping up to date easier with different projects or your product and the projects they use?
So it depends on whether there's a couple of slides that I include here. There's a slow train and then there's a fast train kind of upgrade. Slow train is saying that you don't upgrade for every time you have a new version of OpenStack. I assume that's what your question is. So if you're doing sort of a fast train where you're upgrading with each version of OpenStack, it's a lot easier. If you're doing a slow train, which means that you don't upgrade to each version of OpenStack, you skip a few, and then you upgrade. In other words, you're slow in upgrading because you don't upgrade to every. It's a little bit more difficult, but of course we continue to make that process, easier and easier with Director, which is our, deployment and configuration platform. We've continued to make it easier, but it's not as easy as really the fast train upgrades.
But that's still disruptive, the fast train, right?
The fast train is not, but the slow train is a little bit, yes. Yeah, there's some challenges there, yeah. Other questions? Pete, did I answer that correctly? Yeah. Sort of? All right. Other questions? It's Friday, everybody wants to go home, okay. I think we have one more, right? Marco is on next. So Marco, it's all yours. Thank you.